Good morning, children. I really hope that you all are fine, staying indoor and keeping safe. Okay, now as you all know that Shuhas sir has already started with chapter 1 of geography of your new book. We will just go beyond it, okay? Prior to that, I would like to ask you a few questions. Now tell me, as we are all locked up in our home, just inside the four walls of your room or your apartment, I really know that you cannot go out to treat yourself, but still, I'm sure that all of you like cakes, right? Pastries. Now tell me, be it a fruit cake or palm cake or whatever. So, I'm sure that you have seen the different layers of a cake, isn't it? When your mother just give you a piece of cake, you must have seen the intricate layers, the chocolate layer, then the vanilla, then the spongy cake, then the frosting on top of that, isn't it? We all know it. It looks beautiful when you just cut a piece from a big cake. The piece that comes out, it looks layering. Now similarly, have you ever given it a thought like in this planet, the only habitable planet in this whole system, in the solar system, we live in a planet which is comprised of 3/4 of land and just 3/4 of water and just 1/4 portion of land. What can be inside it? Like how is it from inside? Because whatever we do or whatever our activities are only concentrated on the surface of the earth, isn't it? But how the earth looks from inside? How is it from inside? Have you ever given it a thought? Is it also is it having multiple layers, or is just a one layer, or what are the functions of those layers? So today our topic is about the same, that is inside our earth. We will go deep inside the earth and find out more about the habitable planet in the solar system. Now, for your convenience, I have given the photos of your concerned chapter. Okay, please go through them minutely because we will be giving a reading of it. Now, going to the first slide of it, the name of the chapter is Inside Our Earth, and we are just starting with it. Our Earth, our homeland, is a dynamic planet. It is constantly undergoing changes inside and outside. Have you ever wondered what lies in the interior of the Earth? What is the Earth made up of? Now, when we say that it is constantly undergoing changes inside and outside, it is related to your previous concept of endogenic and exogenic forces. Okay, the endogenic forces enable the earth to modify from within, and the exogenic forces, or the forces of the nature, that modify the surface of the earth in different forms. So it is related to your previous knowledge. You should always carry your previous knowledge when you are moving to the next level. Okay, now interior of the earth. Just like an onion, the earth is made up of several concentric layers with one inside the other. The uppermost layer covers the earth's surface and is called the crust. Crust, similar, you have heard it previously, crust, a pizza has a crust, isn't it? So the base, so the top, okay? So the crust is, the uppermost layer is called the crust. It is the thinnest of all layers and is about 35 kilometers on the continental masses and only 5 kilometers on the ocean floor. So beneath the ocean floor it is much thinner, and beneath the continents it is 35 kilometers of stretch. The main mineral constituents of the continental mass are silica and alumina. So silicon and aluminium are the two main metal that the crust is made up of. All right. After this, it is thus called SIL. SI stands for silica and AL stands for alumina. The oceanic crust mainly consists of silica and magnesium, that is SIMA. We call it SIMA or SIMA, whatever it is. SI stands for silica, same. Ma stands for magnesium. So, if I ask you that how do you know that oceans are denser than the continents? So, your simple answer would be, as oceanic masses are comprised of magnesium and magnesium is heavier than silica, so actually the continents are floating over the oceans as the continents are much lighter. Just beneath the crust is the mantle, which extends up to the depth of 2,900 kilometers. Okay. Now, below the crust, the innermost layer is the core with a radius of about 3,500 kilometers. It is mainly made up of nickel and iron and is called Fe. Ni stands for nickel and Fe stands for ferrous. So together, ferrous is also iron. So together it's called Fe. The center core has a very high temperature and pressure. So as we go down beneath from the crust towards the mantle and core, we see that the density of the materials found and also the temperature and pressure both increases with the increasing height or depth. Rocks and minerals. The Earth's crust is made up of several rocks. Any natural mass of mineral matter that makes up the Earth's crust is called a rock. Rocks can be of different color, size and texture. Okay, before going to the rocks and minerals, I would like to show you something as you can see, the interior structure of the earth is layered in spherical shells like an onion. For your better understanding, I have just shown you this. Just like an onion, when we peel it, we see concentric layers. So one layer lies beneath the other. Okay, so the earth structure is also spherical and it's like onion. Okay. Secondly, I have given you a better vision of the Earth's interior, where you can see the different layers such as lower mantle, upper mantle, outer core, inner core. Also, at the bottom lies lithosphere and asthenosphere. Asthenosphere lies on the upper part of the mantle, okay, and it is semi-solid in state. We also call it LVZ zone or lower velocity zone. We call it so because the seismic waves or the waves that determines the intensity of the earthquake, when they travel through this particular zone, they loses their momentum and they travel very in a slow motion through this particular zone. That's why it's called lower velocity zone. Now I have given you the cake piece picture of the Earth's interior, where you can see the lithosphere that is made up of crust and the uppermost solid mantle. The crust is made up of rock, and upon that we have the soil layer where we grow the crops. Okay. Now next, coming after the crust, we have the mantle, which has the upper mantle layer called asthenosphere or the LVZ zone. Beyond the mantle, we have the core. We can divide the core in two parts, solid and liquid. The outer core is liquid in nature and the inner core is solid in nature. Now you may ask me why the inner core is solid in nature. This question is very relevant and often comes in your examination. The answer would be the inner core is in a solid state because of the heavy pressure of the upper lying layers. Okay, so it is very solid. Now we were reading that the core is also called as Fe. Fe stands for nickel and ferrous. Thus, as it has the concentration of heavy metals like nickel and ferrous, and predominantly because of the presence of iron, the core of the earth creates the magnetic field for us. Okay, so it creates the magnetic field. So as I told you that when we go down from the crust towards the mantle and subsequently to the core, the materials available become dense and the pressure and the temperature also rises. It is evident from the concentration of the metals that we are getting. The crust is made up of silica and aluminium. Once we are moving towards mantle, the concentration changes. We find cobalt as well. As soon as we enter the core, we are getting the most heaviest metals. We are finding the nickel and the iron. Okay. Now let's get back to what we were discussing. Now coming to the second paragraph that deals with rocks and minerals. As we have already learned about the crust, now it's time to know about the various rocks and minerals that the crust consists of, and where we conduct quarrying activities and we get several kinds of rocks and minerals from it. The Earth's crust is made up of various types of rocks. Any natural mass of mineral matter that makes up the Earth's crust is called a rock. Rocks can be of different color, size and texture. Each rock has its own composition, so they vary in color, size and texture. There are three major types of rocks. What are they? Igneous, sedimentary and metamorphic. When the molten magma cools, it becomes solid. Rocks thus formed are called igneous rocks. They are called the primary rocks. They are of two types of igneous rocks, intrusive and extrusive. Now, when the molten magma, so from where we get the molten magma? Of course, from the magma chamber of the earth. When the magma comes out from the magma chamber through any crevices or cracks that has been already formed on the surface of the earth, and if it solidifies inside the earth's surface, then the type of rock that is formed is called intrusive rock. Rocks that solidifies after coming out of the cracks and crevices, they are called extrusive rocks. So igneous rocks are also called the primary rocks because they were the first rocks to be formed on the earth's surface, and they are of primarily two types, intrusive and extrusive, depending on the nature of their solidification. Okay. Can you imagine lava coming out from the volcanoes? Lava is actually fiery red molten magma coming out from the interior of the earth on its surface. So when the molten magma is inside the magma chamber, till it is coming out onto the earth's surface, it is called magma. When it comes in contact with the air, we immediately call it lava. Alright. When this molten lava comes on the surface, earth's surface, it rapidly cools down and becomes solid. Rocks formed in such a way on the crust are called extrusive igneous rocks. They have a very fine grained structure because they are coming in contact with the air, and air is making the rock or the magma solidifies very fast. So the grains of the rocks are fine. Okay, basalt is an example of this kind of a rock. The Deccan Plateau is made up of basalt rocks. Sometimes the molten magma cools down deep inside the earth's crust. Solid rocks so formed are called intrusive. Since they cool down slowly, they form large grains. So granite will be having a large grain than basalt. Granite is an example of such a rock. Grinding stones used to prepare paste or powder of spices and grains are made of granites. You often have seen that in our home, the kitchen slabs are made up of granite. Okay, they are black stones made up of granite. And even the tools that we use for grinding masalas or spices at home, they are also made up of that rock because it is very hard. We use it to grind. Okay, rock roll down, crack and hit each other and are broken down into small fragments. These smaller particles are called sediments. These sediments are transported and deposited by wind, water, etc. and these loose sediments are compressed and hardened to form the layers of rocks. These types of rocks are called sedimentary rocks. For example, sandstone made from the grains of sand. These rocks may contain fossils of plants, animals and other microorganisms that once lived on them. So, very interestingly, when these hard rocks, when the igneous rocks and other hard rocks, they are getting exposed to the natural agents. So, who are the natural agents, or what are the natural agents? We have the air, we have the water, we have the ocean waves, we have the glacier. So, all are the natural agents of erosion. When these are exposed, when these rocks are getting exposed to these natural agents of erosion, the rocks are getting fragmented into different pieces, and subsequently they are forming sediments, and these sediments are getting deposited inside the ocean as a bed of sediments. So, naturally they are forming layers, and very obviously these layers will be very soft. So, as they are forming inside the ocean surface, it is quite evident that the ocean creatures, be it a flora or fauna, are getting trapped or getting compressed inside these rock layers. Thus, their replica is getting imprinted onto the rock, onto that particular soft rock, which is called the sedimentary rock. So, sedimentary rocks will be containing fossils, they are made up of sediments, they are having stratified structure, or they are having layers. Okay, much different from the granitic rock, which are harder. Now, igneous and sedimentary rocks can change into metamorphic rocks under great heat and pressure. For example, clay changes into slate and limestone into marble. So, clay is a sedimentary rock which transforms itself into slate, more compressed form having a different chemical composition, slate. And limestone, also a sedimentary rock, transforms itself into marble, the marble that we use to decorate our floor. It's a flooring rock. Okay. Now, rocks are very useful to us. The hard rocks are, I will be showing you the rock cycle picture once I finish up with this. The hard rocks are used for making roads, houses and buildings. You use stones in many games. For example, 7 stones or pittu, hopscotch or stapu or kit-kit, 5 stones in gitti. Okay. We are getting the names of the Red Fort and the Taj Mahal. Red Fort is made up of red sandstone and Taj Mahal is made up of white marble. We all know. So, they are the evidence that we use rocks extensively from the ancient and medieval period for constructing purposes. You will be surprised to know that one type of rock changes to another type under certain conditions in a cyclic manner. This process of transformation of the rock from one to the other is called the rock cycle. So, from the magma, the igneous rocks are formed, and again the igneous rocks are subjected to natural erosion. They are forming sediments. So, the sedimentary rocks are formed. Now, under certain conditions, again due to extensive heat and pressure, when both the granitic and the sedimentary rocks are getting transformed into a different kind of rock, which we termed as the metamorphic rock. You have already learned when the molten magma cools, it solidified to become igneous rocks. These igneous rocks are broken down into small particles that are transported and deposited to form the sedimentary rock. When the igneous and sedimentary rocks are subjected to heat and pressure, then the change into metamorphic rock. The metamorphic rocks, which are still under great heat and pressure, melt down to form molten magma. So, again when the metamorphic rocks are exposed to extreme heat and pressure, they are transforming themselves into molten magma, and again the cycle starts. So, it's a proper cycle that tells you about the movement of a particular rock. That is why we call it rock cycle. Okay, rocks are made up of different minerals. Minerals are naturally occurring substances which have certain physical properties and definite chemical compositions. Minerals are very important to humankind. Some are used as fuels. For example, coal, natural gas and petroleum. Interestingly, they are also minerals. We use them almost every day. Okay, they are also used in industries: iron, aluminium, gold, uranium, etc. In medicine, in fertilizers, etc. So when we use this we often use this minerals in our industries also. Children, I have just given you a picture of I've tried to give you a more clearer picture of a rock cycle, how it is happening. Just see, when we are igneous rocks, okay, we are starting with the igneous rocks and moving anti-clockwise. Erosion and transportation and due to weathering. Weathering is the fragmentation and decomposition of a rock in various forms. We will be reading about it later. So it transforming itself into soft sediments, mud and sand. Okay. After that, we are getting the effects of compaction and cementation, that is transforming the sediments into sedimentary rock, and then again due to extreme heat and pressure they are forming metamorphic rock. When the metamorphic rock are subduction and subjected to subduction and burial, they are transforming itself into magma. Okay, so here is the never ending chain. Next, I have also shown you about how a particular rock is transforming itself. As you can see, increasing metamorphism is happening over a period of time where shale is getting transformed into slate and subsequently to phyllite, then schist and then gneiss. Okay, gneiss is a complete metamorphic form. Now, I have given you certain name of certain parent rock and its metamorphic form, like shale, from shale slate, from slate phyllite, from phyllite schist, from schist gneiss, from sandstone quartzite, limestone marble, basalt schist, granite gneiss. Try to remember these transformations, it may come. Okay, I have also provided you with the question answers of the concerned chapters. Please try to go through it and try to understand each and every answer. And the diagrams that I have provided here are to be drawn in the copy when you get it. Got you? So, you have to draw this separately and keep it with you till further instructions. Okay. For any query, children, you please keep a note of it and we will get back to you whenever I will be getting back to you in a short while. Okay. Thank you. Have a nice day.